Smiley face.
Alright guys, so we're going to get started. So welcome back to the IOT Deep Dive. This is the first in the series. We're going to be hosting these the first Wednesday of every month to the end of the year. So this is May, then December, so 12 minus 5 is, I'm embarrassed myself here and say 7.
Ready for Saturday, or whatever.
We've got a couple of notes here. Today's topic is Incubator, which is one part of our ecosystem. It's the device side. Later on, we're going to be talking about the cloud side of things in a couple of meetups. So look forward to that. So I guess I should introduce myself. My name is Austin Blackstone. I'm the developer evangelist for ARM Embed. I cover the Americas. If you were at the last meetup, you met my compatriot in Europe, maybe young. If you want to follow me for anything I do, I'm at Engineer Austin or LinkedIn or all that shenanigans. Yay, social. Okay, obligatory part over. So grab the pizza beer in the back. Pizza will show up eventually. Here's the slides and the docs if you'd like them. These are provided as reference also on the bottom of the meetup page, so the invite link. So if y'all would like them, they're also pasted there. At the end of this session, I'll also put the live stream link from my camera that is currently streaming. So hello, YouTube. Right, so the schedule for today. We're going to talk through what has changed, demonstrate and show off the tools. Then we'll get into the workshop section, which should be about an hour. And then we'll circle back around for questions and feedback. At the end, there's going to be a link to the feedback form. My job hinges on getting feedback, so if I could ask everyone to please fill that out and be with the thing, that would really help for me. Also, anyone online, if you see the feedback form, you can fill out post-event, and we'll figure it all out. Yeah, if anyone has any questions, go to social afterwards. So, with that, the pizza just showed up, and I think I've decided. So pause real quick as I decide for that. So, who wants to eat pizza real quick and then keep going?
Let's do it.
Pizza? Okay, 5 minute pizza break. Good. Let's see it. That's good. It's fun. Awesome. I think I got a veggie Hawaiian.
This one's cheese.
Yep. Should be.
What was this one? That barbecue chicken? Pretty nice.
Thank you so much. Thanks. I'm preempting. So I think the lesson learned is for next time we'll set the pizza for an extra 5 minutes or unless it shows up on time.
I expected to like whatever, 15 past.
There's always a learning curve the first time you restart, right?
It's real clear. Thank you. I know what this is. Hey, Austin, I just started an ST. I just went to their technology site over there on the west coast. And I wanted to send them because I think it was module. Got like 6 sensors. What are you working with that? What a small world.
I know, right?
Get it?
You don't want to know what's
Cool. So now everyone's got pizza and beer. I think I can keep going while everyone eats and kind of halfway stitchy, yeah?
Exactly.
So IncubatorOS, as I said, is the embedded side. There's a couple different parts to IncubatorOS. We've got both an online toolchain and an offline toolchain, depending on what you want. The online toolchain is a compiler that just works, TM. We enable this by setting essentially compiler macros and things that are most common that guarantees a successful compile. If anyone remembers in the dark days of embedded systems where it would take a week just to set up a toolchain and hope that everything worked right, those days are long gone. If you use the online compiler, all you have to say is import your code, select your target, and it just works. Likewise, if you do want to have those compiler optimizations, we have a whole offline toolchain. We call it Embed CLI. Embed CLI literally is our backend that we use for the compiler, wrapped up in Python bindings. So no matter what you want to do, we got you covered. We're not trying to push a certain solution. What we're trying to do is enable it. So if you want online, it just works. If you want offline and highly customizable, you go. We're here to support you. Anything else in that? Yeah, that's the basic gist of it. We work with both Mercurial and Git repositories. So if you want to work publicly on GitHub and do all open source, we support that both online and offline. If you want to do a private Git repo that you host inside your company and never sees the light of day, we support that too, because we realize that everyone develops differently and everyone wants their own way to do things. So we just support the Git protocol, and wherever you point it to for your repo is A-OK by us. This demonstrates the basic idea being that you have your repo hosting agnostic from the online or offline tools, and you just use the online and offline tools to interact with them. Likewise, if you want some more intense debugging, we support exporters that allow you to export to common IDEs. So common IDEs are things like Eclipse, Kyle, IAR, GDB, essentially anything you can ever use offline. We support an exporter from your code to that. It is mandated that every embed system supports Kyle, IAR, and GCC, both compilers and exporters, but also run on Mac, Linux, and Windows. So we kind of work everywhere. That's our goal. For connectivity options, so this is the big thing that's changed in the last year since we last ran this series. EmbedOS is the new embedded side of things. Previously, we just had an SDK that had some really simplified APIs for embedded systems, like SPI, UART, I2C. They were just really easy to use. What we've done over the last year is a bunch of work, and we pulled in the Simpsons 5 RTX RTOS into Embed, and so now at the core of everything is an RTOS. That's what makes it EmbedOS. In addition to that, we've added a whole bunch of connectivity stacks, and that was part of our pivot to IoT. So if you want to connect or do IoT, we've got you covered. You want to use an RTOS, you want to do bare metal, you want to use BLE, Thread, LoRa. We've got an NS API for all things IP, so whether it's Ethernet, Wi-Fi, or cellular, it's all covered. Am I missing anything, Baxter? Yeah, got it covered. Cool. So the point is we got RTOS and connectivity, and that's what makes it EmbedOS on the embedded side. And that was a lot of work. So, time to show and tell. Out of curiosity, how many people in the room have not used our toolchain before? So how many people are like brand new to this? 1, 2. Everyone else here has touched the online and offline tools. 3? Brand new. Cool. In that case, we're going to run through it. For those of you who've seen this before, enjoy your beer. Give me 10-15 minutes. For those of you who are new, I'm going to walk you through what everything looks like, because I realize that showing rather than telling is always better. So, let me see if I can figure out OSX. So the website is macOS.embed.com. This is what it looks like. If you notice up here in the top left, can you all see that in the back of the room, I should ask? Is that big enough for you all? Do you want me to make it bigger?
No, I can see it. I'm good. Okay, I'm better.
Okay. There we go. So the basic gist is we have several products. One is Embed OS, one is Embed Cloud. They're denoted by these little things on the top left. Today we're only talking about Embed OS. We'll talk about Embed Cloud in a future event. In the hardware section, we've got the boards that are part of the ecosystem. We've got over 158. For those of you watching online and watching this several months down the road, you probably have way more by now. So the way that you use the board section is you can either filter by which versions of the OS it supports, who the vendor is if you have a preferred vendor and you're trying to go to market with someone. We also have connectivity options. So let's say, I don't know, I just want to use Bluetooth Smart. It'll limit down the boards that have ELE 4 and 5 enabled on them. There's quite a few at the time. So further, if you go and you click through one of these pages, this is where it gets really fun. So this is a board page. Every board page has a pinout for the board. These pinouts are the physical pins on the board. They tell you what they're called in the online compiler. So when we get to writing code later, and you're thinking, well, how do I know what these pins are called? This is where you find that information. LEDs are always called LEDs 0 through 4, 0 through 5, depending on how many you have. Yeah, that's pretty much that. Likewise, over here on the top right, there's a button for adding into your Embed compiler. I've already got this one, so it just says open in my compiler. Further down, you have your instructions for updating your firmware. Because this is the real world, things change over time. Sometimes a board will ship with a package that later on becomes out of date. So if you're ever having a problem with your board, or you let it sit on your shelf for a year or two before picking it up, make sure you update the firmware, because usually that will support all the latest features. Every board page has the instructions in the board page. Likewise, there's code examples for every board listed on the right-hand side of the board page. So if you're ever wondering where to get started, don't ever start from scratch. Always start from someone else's project, copy, paste, and reuse, because in the real world, we're all busy, and we don't have time to do that. So with that, let's go ahead and take a look at what happens when you open it in the online compiler. I found a board I don't have, so I can simulate this a little bit better. So what do we got today? The 411. So here's one of the options that we can have. And see right here, there's a button for y'all in the back. Oh no, my button is just weird. There's a button right here called Add to Your Embed Compiler. And I click that, I get a little notification at the top saying it's been added. So now I can use it with the online compiler. So if I come over here to the compiler, which is this other button at the top, this is the online environment that has all of the defaults preset to just work for your target. It looks kind of like a standard IDE from the 90s. My apologies for that. We are engineers, we are not GUI designers. In the top right here is where you select what board you're compiling for. So I was using a Perl Gecko earlier from Scilabs. Today we're going to be using the 401RE. So I'm going to select that board and say select platform. So now anything I compile will automatically compile for that board. Behind the scenes, what just happened was by changing the target, I changed the pin map that it has, I changed the underwriting drivers that it has, and all that was just taken care of by clicking on that one GUI element. For now, if I want to go create a new program, we've got the option up here. Likewise, you can import existing programs. As I mentioned, you can import these from Git. So let me delete this one as an example. So for example, we have found those new Mac laptops that only has USB-C ports. Does anyone have an adapter with them at the moment? Nobody? Maybe an adapter in the audience so I can do a programming demo? Anyways, what we have on that? This is the one I got, right? So I'll go over here to the top right. This is a 411. So there's the 411. Now I'm going to go import some code. I happen to know that on OS or GitHub, the OS example DLE. Nope. I happen to know that this is the address of a particular Blinky example that works with EmbedOS. Likewise, if you were developing your own code, you have it in your own personal repository. What I'm going to do is take this URL of the Git repo, copy it, click import. I click on import. There's a little thing right here that says import from URL, and I just paste in the URL address. I'm now imported my own compiler.
That's killer.
It just works.
It's amazing.
Likewise, if we go back to the board page, for every board, there's an example right here. I could just as easily go to that example page, and on the top right, there's a button that says imported my own compiler. It'll do the exact same thing. So whether you're using code that is hosted on our website, code that you have hosted in your repos somewhere else, it all just works. It's all just the same import from URL link. So I'm going to go ahead and import that. It's going to be, right now it's pinging out to Git, doing a Git clone. It's then doing an embed net on it, setting the target that we just set, and now it's good to go. So if I were to compile this, I click on the, still in the back, can't see that. There's a compile button up here. So when I click on compile, what just happened was I kicked off the script on the server. The server's going, okay, let me multi-process these probably 30 or 40 different cores all at once to pipeline your binary and get it compiled. And it's going to compile in about 10 to 15 seconds, much faster than you'll ever see it compile on your machine. So I really like using this for demos because by the time I'm done talking, this thing in theory should give me a download to download. And it looks like I'm a couple seconds short on that. But anyways, it's going to send back a thing. It's going to pop up in the bottom left here. Magic. So I know it's a little bit small, but right down here on the bottom left, that is my binary.
Oh, where does it put that?
Right now I just downloaded my downloads folder because that's what I have set up. Let me show you. So, can you guys in the back see that? There's my... That's not going to increase, is it? Oh, darn. This is my downloads folder. It is completely illegible to anyone past the first row. And that thing on the top says EmbedOS example Blinky _ nucleo F411, which is the board that we targeted. I could then drag and drop this to my board and program it. When I plug the board in, it shows up like a USB drive.
You want to borrow my notebook and do it?
Do you have the dongle?
He doesn't need one. No, USB.
Nah, because I'll take 5 minutes to recount the airplane and all that.
Okay.
Point is, these boards show up like USB drives. So you plug them in, it says embed instead of USB stick. I drag and drop that onto it just like copying a PowerPoint presentation, and the board will program itself. And then it'll restart and start blinking LEDs. The one time on Windows is actually better than an OS X machine, right? So that is the online experience, and that's what we're using a bit to compile these programs. Any questions, any concerns, any cool things that you'd like to know about? Yes, sir?
What about legacy boards? Like I don't see a K25 on here.
Oh, K25 is there.
Oh, it is.
Yes.
It's just missing.
So if I go back to hardware and then boards, Control F, K25.
Is it KL25? Not K25.
Oh, yeah, probably. KL25. Yeah, there it is.
Oh,
KL25.
thank you.
So it's right there.
I have a couple questions. One is, do you support that old kit that you guys used to sell that had like the 2 backplane boards and had like a K16 processor on it?
Talking about the hexaware?
No, I think it's talking about the embed kit with AT&T, I guess. So So yes,
Are you talking about the AT&T IoT kit?
No, this was from years ago. I actually bought the kit
Do you have a
years ago.
picture of what it was called?
Oh, I can't remember what it was called. I'd have to look it up. I still have it, and I bought it because I wanted to do Linux on it, but then I found out it had no memory management in it.
So the short answer is if it's listed on this platforms page, we support it.
Okay.
And if it's not listed on this platforms page, we don't support it.
Okay. It was a free scale product.
So you can go over here to the left-hand side and select free, what are they called now?
it's now an XP.
Right, so select NXP semiconductors because Freescale was bought. This is a list of all of their platforms. And so I would recommend scrolling through that, and that'll tell you it's there.
Okay.
We do drop some vendors over time. As the ecosystem advances, some vendors choose not to update their products. And so in the interest of keeping it easy for everyone to navigate just work, we always give vendors a chance to update their software, but some of them choose not to, and they get taken out over time.
Okay, so second question.
Yes, sir.
I did some work, I learned to use this embed OS and all that. Now I want to make my own custom piece of hardware. What do I do? Because I'm not going to be able to pick it there.
Right. So there's a much longer explanation of this that I'm going to say let's talk about later.
Okay.
Because in August, September is when I'm targeting to have a workshop specifically on how you go to production with everything.
Okay.
But the long short of it is we are focused on that. We're working on a thing to enable it, and it's not here today. That binary that I just downloaded is a production binary. You don't have to change a thing to go to production unless you change your pinouts, in which case you just change your pinouts and you're good to go. If you would like to compile that online, do overrides. We have a whole override section in the config where you can override bin names, and you can do that. Or you can pull it offline with offline tools and do it entirely there, as much customization as you like. So the TLDR on going to production is you can ship that binary we just made. If you want to change some stuff, modify the code to do that. If you want to publish your platform here, like if you're interested in building something really cool and then pushing it back up onto the website, we have a program called Embed Enabled, which is specifically geared towards partners and community who want to bring platforms to the ecosystem. It's about a 6-week process right now, and it's pretty stringent, so you gotta have like some really cool features or be pushing the bench or something, but it is entirely possible to do.
And is there a fee for that?
I honestly don't know because I'm not part of that team, but during the Q&A, you can talk to Dexter back here. Dexter, would you wait, please? So Dexter is on our PE team, and he can tell you all about the process because that's part of his job. All right. Cool. Yes, sir, in the back.
Could you talk more about that production series that you're going to have in August?
Can we do it during the Q&A at the end?
Sure.
Sweet.
I'll give you a chance to plug it.
So we are having a production series. Keep watching the meetup and the events page of our website for more information. Coming later this year. I'm not going to commit to a date because marketing will kill me if I commit to a date. Cool.
Thank you.
Thank you, sir. So that is the rough gist of how you compile code online. There's a whole bunch of other really cool stuff you can do with that. I'm going to talk about a few features of the website that I want to highlight so that you all are aware of them. Under the hardware section, we have a section for modules. So this kind of goes to y'all's question about going to production. We are encouraging going to production. The way small batch vendors, less than 100,000, even less than 1 million units, go to production is using modules. It's not necessary to use a module if you don't have connectivity. But nowadays, for IoT, you have to have a way to connect to the internet, right? Whether it's Wi-Fi, cellular, Thread, LoRa, NB IoT, whatever you're using, you're connecting to something. If you're connecting to something, that means you're emitting a signal. If you're emitting a signal, that means the FCC wants a piece of your pocketbook to get your product certified. That can be really expensive, like more expensive than I make in a year in my entire salary, kind of expensive. Modules are how you get around that. Modules are a pre-certified little PCB, and instead of laying down the radio and laying down the MCU and all this stuff, what you do is you buy a module, you pay an extra 20%, and then you don't have to mess with the FCC. It comes pre-certified, it's guaranteed to work, you can't change anything that's part of that circuitry, and you ship that in your larger product. So instead of putting down the PHY, the radio, and the MCU, what you do is you build out your product and then you just put a module down, and so you solder their PCB to your PCB and you ship that. That is how you avoid a lot of regulation. That is how you go to production faster. To that end, we have a bunch of modules here currently listed. I think there's 4, 5, 6, 7. 7 as of today. I can say that there are several more that are not public here that are going to be public in the near future. And we're increasingly shifting our focus to modules as a way to enable people to go to production, because we are very much about prototypers who want to build something and who want to get out there. Yeah, that's pretty much it. So if you're thinking about going to production with something and it has a radio, I recommend using a module because it'll save you a ton of headache later. We're going to have modules that just work with Embed in the same way that other stuff has. So all you'll have to do is then add drivers for your component, whether it's like a SPI flash or whether it's just an LED, and then changing the pins. And that's all you got to do. To that end, once you have a module, you want to add stuff to it, because you're not just going to ship a module, right? So under the hardware section, we have a thing called the components database. The components database is a bunch of common drivers that we've been building up for the last decade. How many guys in here are embedded engineers? Like who writes embedded stuff for? One of the biggest problems in embedded engineering is whenever you get a new thing that you want to use, you almost always have to write a driver for it from scratch. Whether that is a motor driver, whether that is an LCD driver, whether you're writing even just a really basic, what else are really basic ultrasonic sensor driver or an IR driver, you have to write the software that interfaces with that piece of hardware. And to be honest, it's not usually unique. Someone else has done it before you. In fact, someone is probably doing it at the same time as you. So there's no real reason for you to have to read that data sheet, figure out what's going on, find the corner cases, and spend anywhere from a week to months of your time getting that driver working when someone else has already done it. A large part of the embedded ecosystem is focused around reuse, and that's why we like the open source and like the community aspect of it. If you have something you are trying to do code with, odds are someone else in the community has done it, and they've either posted it in the components database or they posted it in the forum, both of which are searchable. So if you're ever going to try and go to production, say, get your module, find what hardware you're using, search the components database to find a driver, because at that point you just import the driver code, you set your module as your target, and you're off to the races. It simplifies it from weeks and months to minutes. I should mention we also have some really good generic drivers in this database. Most LCDs these days are supported, especially all the line LCDs. If you buy a line LCD out of China, for example, it may be 32 by 4, it may be 16 by 2. They all work on the same principle for the most part. It's with a generic driver. You modify, I think, 3 config parameters, and then it just works for whatever line LCD you have. So we even have some really good generic ones, and it's not the exact one that you're looking for. So I wanted to point that out. In addition to that, there's the documentation section. The documentation has got 3 major sections to it. There's the reference, the tools, and the tutorials. Reference is our API docs. So if you want to know how to do I2C, there's an I2C page that documents it with API and examples. Likewise, if you want to know how to use the RTOS, the thread system, the event system, just go ahead and open that up for you. It has a whole bunch of really good stuff. So like right down here in the APIs, because we're just going to skip to the meat of it. You'll look at RTOS, there it is, and there's all the RTOS drivers. If you notice, we also have a Bluetooth stack, LoRa stack, security, storage, and we're adding to this over time. I should mention that EmbedOS has a quarterly release cycle, so major new features like new connectivity methods are added every 3 months. Every 2 weeks there's a patch release, so if there's something that's broken, we'll fix it within 2 weeks. New features come every 3 months. So like the next one,
June 15th.
June 15th?
Around June 15th or mid-June is our next release.
So June 15th is the next one, and what is one of the major connectivity things we're adding?
I think this time we would be more, I think we have just added the cellular, specifically the NB IoT and CAT M1, which are some of the leading technologies for the connector for the IoT Incubator. So I think it would be focused on having some, having a robust implementation of NB-IoT and CAT M1 this time.
Cool. So those are 2 new connectivity methods that will be added in the next minor release, and they'll get docs here. That's the gist of it, really. We also have questions and forums. Those are pretty self-explanatory. That's the end of my thing on the online section. Any questions, thoughts, concerns, existential crises? Good to go? Guys in the back who also work in my team, did I miss anything? Cool. Yes, sir.
You mentioned, like one of the first few slides, that you could be online and offline, and I noticed here you show Kyle again. So if you go online to do this, do you have to purchase a compiler, or is it an open source compiler that you can run?
I'm glad you asked that question. Let me show you. So back in the compiler, if you want to, his question was if you want to export to an IDE, how do you do that? And then what are the options? So to do that, you right click on your program. There's a little button right here that says export. You can export your program. The window is going to pop up. As it's supposed to. I think there might be an AirPlay lag going on here. Yep.
Yeah, you got visual delay there.
Yeah, we got some massive lag happening. That's great, because there's a window right here that's being hidden and obfuscated. Let me try and pull this off into a new.
He's got a zillion things open.
Yeah, that might also be a small issue for me. Tell you what. Let's just do this, pull it over here, that'll cache out, and maybe OSX will continue to work. So OSWZ.com, so let's go back to where we were. My apologies, that was not the website, that was my machine being flaky, because I'm doing too much. That's right, here's our program, right? We right click on it, we say export, it pops up a nice little window, there we go. It lets us select our target for the code, so if we want to change it, we can, and more importantly, it gives us the toolchain options. These are all the different toolchains that this vendor has chosen to support. So to your question, you're asking specifically about Kyle. Kyle and I are both cost money. That's just a fact of life. I don't control that. My apologies. If you are using them in a professional environment, odds are you're using one of those too, so we support it. But if you would like a free environment, we also support, if you like makefiles, if you're a command line guy, we got GDB with makefiles. Likewise, we have an Eclipse exporter that I think has fallen off the bottom. No, there it is. So here's the Eclipse exporter. So it supports Eclipse with GCC. So if you'd like a free one that works pretty well, there's always Eclipse. There is also a thing in alpha right now called Embed Studio. We're kind of putting together a thing for an offline free one that's really awesome. If you're interested in it, you can go Google it to check it out, but it's at an early offer right now, so look forward to that when it goes off. But yeah, there are options for free for good offline debuggers. Cool. Any other questions? All right, I'll keep going then. So, slide.
Austin, do you know anything about the format that gets exported to? The format that it exports to?
Oh, it exports project files.
Okay.
So whatever the project file is for that IDE, so if you're doing Kyle, it's a .uvpjt. If you're doing .eclipse, it's like .workspace, I think.
Okay.
If you're doing the makefile thing, it's .makefile. It exports them to whatever the project files are for that IDE, so if you just double-click it, it opens up in that associated workspace.
Oh, that's awesome. So you never have to be concerned with what's inside the file.
Correct.
Right.
That is the goal. And now if I could only find my slides, then that would be great. Right, so that was the online one. Let me talk about the offline one. So for offline, we have Embed CLI. Embed CLI is pretty straightforward. Oh, where'd it go? So this is my embed CLI. I'm going to take a second and make this bigger because you guys really can't see that in the back, can you? Let's say, oh, there's rhythm. Oh, God bless. All right, can you all see that in the back?
Mm-hmm.
Okay, so. Yeah, cool. Cool, so this is the directory I'm going to play in, right? So is everyone here familiar with Python? Who does not know Python?
I don't use it on a daily basis, that's for sure.
Okay, so.
Everybody else here is Python pros, is that what I understand?
Not pro.
So Python has a package manager that's associated with it called pip. So pip allows you to get things from the internet and install packages. That's what it's good for. The one that you want in this case is called embed CLI. So if we say pip install embed CLI, it'll go out and install embed CLI. Turns out I already have it installed because of course I do, it's my job. Embed CLI is just run by calling embed. Let me go a little smaller. A little smaller still. Cool, now you can see it. Those are all the commands that embed CLI supports. The ones that we are going to talk about right now are import, and then we're going to talk about compile, detect, and export and config if you're interested. So remember that website we went to earlier? It looks like that. So that's the URL. I'm going to say embed import that URL. Remember that URL is just a piece of code. No, you can't see that. I'm going to put it bigger again. Everyone see that now?
Yeah.
So that piece of code is just an embed project that we built that sits out on a GitHub URL. It could just as easily be on a Mercurial server if you prefer. When I say import, it goes out, it does a git clean out of the machine, it sets it all up for me. Wow, the Wi-Fi is slow here. So what's going to happen is it's going to pull the code down, and then we're going to compile it. Again, just to reiterate, this is the backend that our online compiler uses, just in a Python binding. So anything you can do on the online compiler, you can also use in the offline embed CLI tool system. It's also called the same thing. So that compile button will just be embed compile. That export that we did will just be embed export. That's all that it is. Pretty sure I actually have this somewhere. Let me just go ahead and CD into that. Yeah. Okay, cool. So, assuming that it keeps downloading, this is what you'll get. What I can do then is compile this. So if I say embed compile, let's see what it has for options. So the compile options on this, the big ones to pay attention to here are target and toolchain. These are the two things that you need to run a compile. Just like in the online compiler, where we select our target in the top right by clicking on the GUI, and then in the background of the online compiler, it automatically uses GCC, or sorry, ARMCC. Here we just get to specify which one we want to use. So I'll say embed compile target. God, I forget what this is called, so I'm going to use a different one. I know this is a valid target name for a different board I was using earlier. And then I can say -- toolchain GCC ARM. That's the ARM, that's the GCC toolchain for the ARM stuff. That's the right keyword, right? Cool. Gonna write compile. Huh. Well, that's super annoying. got no idea what went wrong. I've been messing with this a whole bunch. Looks like I've managed to corrupt my install somehow from earlier because I was trying to build 7 new things. Have anything else we can use?
No, we believe, that's cool, move on.
Yeah. Anyways, I'll take a sweet time. Is anyone actually interested in this room in offline tools? Because I can go on about this forever because I really like it and I nerd out about it and I helped build this thing, so I'm really passionate about it. But I realize some people might not care less. So can I see a show of hands who actually wants to learn about the offline thing? 2 guys? Okay, 2 versus 20. I'm going to take that as a, we'll move on and we can talk about it in Q&A. Is that cool? I've also got a whole video playlist on our YouTube channel about the really cool stuff we can do on it. I'm so passionate I write videos that no one watches. It's great. Okay, so the point is offline tools, online tools, no matter how you want to work. If you want to do automation offline, you can do that. One of the other really cool things that you can do here is with embed. Sorry, I'm just going to change over here so I can share this stuff again. We have a test command. We believe that testing is the way to do everything for embedded systems. Test-driven development is a very, very important thing. These things are getting more complicated. You don't have tests, it's going to blow up in your face. We have a whole testing thing built into this. You can also set your configuration options globally, so if you don't want to type the target name and the toolchain name every time, you don't have to. You just say, config global target is this, config global toolchain is this. Then you never have to do it again. There's even a really cool thing where you can set the target as auto. So it'll automatically detect whatever's plugged in and just start compiling for it. Because I forgot my dongle, I can't show you that. But trust me, it works. There's also a giant list of everything that is supported. So I'm going to say embed. Was it embed dash supported? Apparently not. Every subcommand has its own help menu. So if you want more details on what you can use with compile, for example, it tells you, some example names, some example names.
Dash S, it says.
Oh yeah. Compile dash S. Now again, something's wrong with my local thing because I managed to corrupt my machine apparently. My apologies. It should print out a giant list that lists every target, every tool chain, and whether or not it's supported and whether or not the compiler works. So if you have any doubt about whether it works or what the tool chain name is, dash supported will tell you what it is. Okay, that's pretty much it. Because it is a command line tool, if you want to manage your repositories, you just use git. You commit to it, you push it, you clone it, you PR it. Also works with Mercurial. They both just work. As you can tell from that one, even though I gave it a git URL, it just handled it. So it just works with git. Okay, so that's all the cool stuff. So on that note, let's go ahead and pass out some boards, and we are going to get to talking about how to write some code with EmbeddOS. So now begins the workshop section. Sound good, guys?
Right.
Austin, do you want to talk about the GitHub org that we use, and what the naming pattern for the examples?
Ideally, they'll find everything through the platforms page. No one should have to go directly to the GitHub org at all. That's an issue with our documentation system, not something that we should actually be advertising, I think. So if anyone's interested, the examples are on the example pages. The docs also have links as do the API references. So if everyone could come up and grab a board for me. Grab a board out of the box, and then also grab a USB cable. I'm going to go grab anything from the front desk real quick.
It is, far enough, but I'm never on it.
I think any more.
I have a dongle.
Push down to my machines, causing problems.
Yeah, what do you need this time, right?
Maybe we'll come back.
It's having issues because I got my VM open. That makes sense. Alright, so coding. Everyone's got a board, everyone's got it connected. Everyone good? Cool. This is the point where I introduce my coworkers. We're going to be walking around helping everyone out as we have to debug. This is Mohit waveforming. And this is Dexter sitting right next to him. Both of them work with me on the ARM office on Embed. So if you all have any questions as we're going through the code or you run into any troubles, just grab one of them and come over and help you out. So the first place we're going is here. Whether it's in the online compiler or whether you want to use the offline toolchain, go ahead and import that into your import it. We're going to compile it, and then we're going to run it on your board. We're then going to try changing the speed of the blinking LED, try changing, depending on what board you got. If you got the white boards, only change the speed. If you got one of the red or black boards, it's a tricolor, so you try changing the color of the LED. So, go for it, guys.
I'm supposed to remember my embed password.
And by the way, this is me showing you how it programs. So like right down here, Dappling, it shows up as a USB drive. I drag and drop the file. Should be programming. Huh. Whatever. Oh, it's still copy. You can see it copying the board right here. When it finishes copying across, it'll reset and start blinking the LED.
It's not copying anything. It said 0 bytes or whatever. It's working today.
I worked earlier today in preview, and of course, as soon as I get up here live, everything goes sideways. The demo gods do not smile upon me. Okay, there you go. Sorry about that, guys. There you go.
Austin,
Yes,
can you
sir.
provide instructions on how to import, compile?
We just walked through that.
Sure, but just a moment.
So everyone got the link copy? No, not working?
Well, I'm trying to reset my password. It wants your username and your email address. Too much. Whatever.
And so this is the code running with the super tiny LED right here that's blinking. That's what we're going to be trying to get to work.
I just remember when
Okay, let's just sign it for you then. Go ahead and click on sign. There you go. This is your partner?
Yeah.
Pleasure to meet you. Austin. Good to meet you. Good most.
Oh, yeah, this part you gave on mine, I'm sad.
Yes, sir. Yeah, this one target. So, if you want to change the target, it's either up there in the top right, or an easier way to Dashboard, you can. Okay.
Well, free of them.
Click on embed each step.
Is that some?
That's great, yeah, most likely.
Now,
And then, so it's been added to your compiler? Yeah, I'm already added. Okay. So now if you go back to your compiler in the top right. Okay. There you go. Okay. So. Yeah, boss.
well, I'm still trying to log in. I'm getting there.
Yeah, so you've got the split in the top right is the one that allows you to select the board. In the top right, up there of your screen.
Oh, I see.
Yeah. That'll allow you to go choose a board.
Everything goes on?
So yeah, so that board there.
Absolutely, yeah. That happens during the workshop. That always happens during the workshop.
Yeah, check it underneath.
It's required.
Yeah. I kid you not, right before I walked in here, I was compiling that, and then I have no idea what's going on with it now.
You know, otherwise it's too good to be true.
Yeah, exactly. It just works, it's boring.
Exactly.
When you click that ad, does it go away? Your board.
Yeah.
If you go to the platform page, then you can just click the button directly from there. Pull up a new tab on the platform page.
You ever seen that?
Yeah.
Yeah, they pushed some update and now it's this and I get a black screen.
Yeah, and then you click on that board that you got. There's a button, right, to say add.
It's, that happened a little while back. There's like a shift Alt F4 combo you can do. You can purge your P
RAM,
Yeah, you can purge that and it should work.
Yeah, I did that, but.
I usually just do a control F and search for whatever it is. Command, Option, P and R.
That one, yep. Including that, just clear everything and then accept your hardware, of course.
That's it.
So click on that.
Right.
It's this one here.
This is where I get to take it easy and actually drink my beer and eat my pizza.
Yeah, and on the right side, it'll have a, scroll down a little bit, you should have a
Yeah, I got it compiled all the way around.
So, did it say the binary? When you do a compile, you do a
Oh, and I got to transfer.
yeah, you just drag it over.
It's setting us
What's its name?
So these are boards, these are boards that we got from our lab. Usually we have really good. Yeah, so that was a bad board. Sorry about that. And,
Click the top one.
these are, always have a lab, so it's really good.
Oh, there it is.
Click that, and then select platform.
Oh, okay.
And if you get a whole bunch of them, they'll show up. So now it should say your board is there, that's how you know which target you're going.
So usually for your test.
Well, it looks like that changed something. Let's see what happens now.
Yeah, and you drug it over there, did a reset on it?
I didn't do anything.
Alright, so I got your.
I moved the file over.
Okay, yeah, so if you want to go look at, back at your compiler page and pull it by flavor on CPP.
Something curious though.
Go to the.
You won't see it. So it actually programs it on the chip when you do that.
It's real tiny. We need like a bigger box. I think you also right click on the program.
Pull it in CPP.
are
And see,
recyclable.
just change the time to something quicker, so like,
That should be okay.
you could do weight, underscore, if you do weight underscore your mass, then you could do like weight underscore your mass. 200.
workshop forever ago.
You should go with that.
Actually, I had this blinky thing in here, but I deleted it, so I figured it's probably that big. I'm like, all right, if I can look at it, that was.
And then compile that.
I just found this one.
And then, once that's
I might have
done,
multiple tabs over and all.
I did, I'm already there. I'm just on the device doing a warning on S3 bug. Can't read this stuff.
does it show the master
Control
device
plus plus will make it bigger.
in your My Computer?
Control plus plus.
Yeah, there it is.
Yeah, so you should be able to copy the binary over there.
Yeah, I can.
Is that I try changing the speed? So the file you want to open is
That's it.
200, right?
Yep, there you go.
Awesome.
Yeah, you bet. You roll right through that.
So I just take that, and I just drag it to the approve.
Yep.
There's one back here, you got roll.
Alright, so I just
There you go. Now go.
imported it, that's right, now I just need to compile, that's right, just gotta get that, now it's just a matter of compiling, and then dragging it up.
Okay, then. How you doing with yours?
Make it weight.
I'm good.
Okay.
MS for milliseconds and switch to 0.5 to 200.
In the past, there's been issues with save as to the board. I remember some glitches with that a long time ago.
Yeah, if you try it, so when you compile it, you can either save it directly to your board,
Yeah,
but depending on what OS you have, and whether it's using cache forwarding, like both Apple and Microsoft at different times have tried to do this really smart optimization that breaks our MCUs. And so when in doubt, just save it to your downloads folder and then drag it.
all right, because it's caching the old one. It's not updated. The first time I.
Yeah, there were some drag forward cache issues a couple years ago, so if that does not, just save it to your machine and then copy paste it.
Well, see this guy. He's not on drive. That's a problem, right? So.
So it looks like most people have got it either compiling or in the process.
Okay, so on there.
So I'm going to take a look at the code here.
Thanks.
Yeah.
So this is the code that
It's
we're
not
running.
showing that. It's not drawing.
If you look at it,
So-
all that this thing is doing is running through an infinite loop here in main. It's turning it's changing the LED,
Yeah, no, all right.
and then it's waiting for a bit, and then it's changing the LED, and it's waiting, and it's changing, and it's waiting, and it's changing, and it's waiting ad infinitum, going on forever.
Nothing?
That's all that's happening here. And so if we want to change the speed, we change the wait
Could
period.
be.
I had that problem.
So try changing that wait period and see it happen on your board. Try doing,
Let's see if it comes
try opening up to 1. I'll just turn it on for a second, off for a second. And then try changing it in a different pattern. So try mixing up some weights and change state
Yeah,
sequences.
what is regular?
See if you can get to blink SOS.